Hello everyone, Miss Demmer here. Today our I can statement is I can solve one-step algebraic expressions. Now the notes that I'm going to show you are multi-step. We're going to be taking this day by day and doing one step, two step, and so on, but I want you to have all the notes for all of this. So I will have the notes attached with this. I'm just going to review over it. So yesterday we talked to the last few days we've been talking about the distributive property and making sure we're doing that first. Then we combine our like terms. We've been talking about that also. Then we get the variable to one side. The problems that we have today are already going to have the variable on one side. Then we get our number on the opposite side of the variable. So see how my variable is on this side? I want to get it on the opposite side. Then we undo the multiplication division. So like here, we're multiplying, so then we're going to divide. Check your solution. You simply put whatever that number is in for your variable of x. Okay, now we're going to put this into play. So Marcy took her secret number, added 5, doubled the sum, and subtracted 2. Her result was 58. What was Marcy's secret number? Now think about this. If we would work backwards, we could figure this out. But with that being said, we'd have to do the opposite of what she did. Because if she subtracted, that means the number was too bigger than that to start with. So we're going to be doing the opposite here. So we have 58. She subtracted, so we're going to do the inverse operation, the opposite. So that means we added 2 to get 60. Then we doubled the sum. So if we doubled the sum, doubled means that we multiply by 2. And if we look at our clue words, we can see that. So we're gonna, if we can't multiply by 2, we have to do the opposite. So we're gonna divide by 2. So 60 divided by 2 gives me 30. Then if they added 5, we have to subtract 5 because we're doing the opposite. That gives us 25. So the secret number was 25. So, what steps did you complete to find Marcy's secret number? We worked backwards and did the opposite operation. So we worked backwards and did the inverse operation. How'd you know what steps to complete and in what order to complete them? Well, we did everything backwards and then did the opposite operation. We knew to do that because in order to get that number, if they subtracted 2, that means we had to add 2 more to it to figure it out. Okay? Now, we are going to do some problems. We are going to be doing the inverse operation. So if you turn to page 293, we're going to be solving these problems. So looking here, I have 4,509 equals x minus 748. Looking at your notes there that we had at the beginning, I just want us to get in the habit of using those as we're doing algebraic expressions. I know we're starting out little, but as we get into multi-step, it's going to get more complicated. So we do not have the distributive property here. Like terms are both on both sides. We get the variable on one side, ready, have that. Now we have to get the number on the opposite side of the variable, so we do the inverse operation. So you see in front of here, if we had our line, this is minus our negative 748, so we're going to add 748. The reason we do that is because we want to get that to 0 to get x by itself. So if I do that to one side, I have to do it on the other to balance my equation out. I add that. And I get x equals 5,257. Now in order to check this, I am simply going to do 5,257 minus 748 is all I'm doing is I'm putting my number that I got into the equation. Can't do 7 minus 8, so we borrow. 17 minus 8 gives us 9. 4 minus 4 is 0. Can't do 2 minus 7, so we borrow. 12 minus 7 is 5. And then that gives us 4, so we get 4,509. We got the same answer here, so we have that correct. Okay? Same thing with number 2. We don't have the distributive property. Combine like terms on both sides already. Get the variable on one side, already have a variable here. Get the number on the opposite side, so we need to move this 7 over here. This is really a number y divided by 7. So if we're dividing now, we're going to multiply by 7 over 1, because that gives us 1y. That gets y by itself. Okay? If I multiply on one side, I have to multiply on the other side. So we have 18 times 7. 8 times 7 is 56. 7 times 1 is 7, plus 5 more is 12. That gives us 126. Now to check it, we're going to do 126 divided by 7. So I have my 126 divided by 7. I can't do 7 into 1. 7 goes into 12 one time. We subtract, that gives us 5. We bring down the 6. 7 goes into 56 18 times. Our answer right here is 18. So we did it correctly. Number 3 and 4, I want you to try on your own and then check to see, make sure that you're doing it right afterwards. So again, I don't have the distributive property. They already combine like terms on both sides. The variable's already on one side. Now I have to get this decimal over to the opposite side. Well, since it's plus 2900ths, I'm going to subtract 2900ths. That cancels out. If we do it to one side, we must do it to the other. Can't take 5 minus 9, so we borrow. 5 minus 9 gives us 6. 6 minus 2 is 4. 5 minus 0 is 5. We bring our decimal straight down. So D equals 5 and 4600ths. Now to put this in, I'm going to do 5 and 4600ths plus 2900ths. Remember, when we add and subtract, we line up those decimals. 9 plus 6 is 15. That gives me 6, 7. Bring our decimal straight down, 5 and 7500ths, and that's what's right there. So we're good to go. Number 4, don't have the distributive property. They already combine like terms on both sides. The variable is on one side. We don't have a variable on this side. Now we have to move this 5 to the opposite side. Now if this is 5 times k, or 5 times a number, since we're timesing now, we have to divide. So we're going to divide 1 2/3 by 5. Well, when I do this, I need to make this into an improper fraction. So 3 times 1 is 3, plus 2 more is 5. Leave our denominator the same. And then this, our 5 is 5 over 1, because it's the same thing as 5. We do keep, change that to multiplication, and then we flip this. Now something cool that I always do is I always look across, and I might say, okay, is there any number that can go into 3 and 1? Well, 1's here, so it's going to stay the same. 5 and 5, I know 5 can go into that, so this becomes a 1, and this becomes a 1. That gives us 1/3. So k equals 1/3. So then we put our number back in. So we're going to do 5 over 1 times 1/3, which gives me 5 over 3. Is that the same thing as 1 2/3? Well, 3 goes into 5 one time. We have 2 left over and our denominator stays the same. Yes, so our answer is correct. Now I'm going to go over the home link with you in just a second. So what we are going to do here is, it's going to be very similar to what we just did. So this is your home link. Up here is just like what we did with that problem where we worked backwards and did our inverse operation. Up here, we're doing inverse operation. Make sure that you check each of these. Look back at those math journal pages. Make sure that you're doing it right. Okay, there's an example of each one of those that will help you. Down here, you're finding unit rate. So if I want to find pages per minute, I'm going to take 55 divided by 10. All right, have a great rest of your day, 6th graders.